Good morning, everyone. My name is Kishend Raj, son of Sangralingam. I'm from one of the PSM2 student from University Technical Malaysia, Malacca. And my supervisor name is Dr. Zudina binti Samsudi. My project entitled Theoretical Prediction on Physico-Mechanical Properties of Reclaimed Carbon Short Fiber Composite for Composite Repair Application. And for the introduction, the recycling of the reclaimed carbon short fiber from the trimming waste in aviation industry and mix it with other suitable polymer for repair application, as it is proven that the carbon short fiber has degrades its properties such as tensile strength and also Young modulus. The influence of filler loading on the physico-mechanical properties is predicted using mathematical approach and ansys simulation. This composite is suitable to be formed through extrusion process, and the effect of filler loading on the parameter, which are the speed rate and the temperature. Based on the research made by Shankar Karapunan Gopalraj and Timo Karki, as the reclaimed carbon short fiber from the aviation waste can retain 75% of the tensile strength and the Young modulus. For the objective of my project, the first one is to predict the influence of filler loading on the physico-mechanical properties using a mathematical approach. And the second one is to evaluate the effect of extrusion parameters such as the temperature and the speed rate on the filler loading. And the scope of my project is, when we see for the material, we use ABS and reclaim carbon short fiber. The physical properties is density of composite, mechanical property is the tensile strength and the Young modulus. Extrusion parameter is the speed rate and temperature, and the method used is by mathematical approach and ansys simulation. For the problem statement, in aviation industry, most part of the aerospace is made by carbon fibers because it has high strength and also low density. However, from the waste from the trimming process uh, has a low tensile strength. Hence, the suitable matrix has selected to prevent the high viscosity of the molten, which can reduce the flow rate and increase the pressure of the extruder. And from the research by Chris Rowendell on the year of 2016, we can see when the barrel pressure is high, we need to add more specification where we need to increase the temperature. And this will cause the composition to form in improper way. And from the figure below, this is the normal, a good mixing of the composite in a twin screw. And because the red region is low in the figure, so it means the pressure is good. And for the literature review, we choose ABS because when we compare to polypropylene, the composition of polypropylene and carbon fiber has high processability and recyclability, but it is low in strength. To improve the strength, we need to add some nanofillers where it can increase the pressure, and also the flow rate will become low. For the ABS, we can see the tensile strength is slightly low from the polypropylene, but it has a good tensile strength for a repair application. And for the literature review on extrusion parameter, we can see when the temperature is high, the flow rate is also high, and the viscosity drops. This means it has a proper mixture of the composition. And when the temperature is high, the pressure is also low, and this will produce a good composite. And when the speed of the screw increase, the flow rate also increase. This means the pressure is a bit low. And from the literature review, the proper temperature and also speed rate is obtained, and the result of tensile strength and Young modulus value is used for mathematical approach and also the ansys simulation in the chapter 4 for the result and discussion. And for the methodology of my project, the first one is mathematical approach. We use the tensile strength formula of as shown in the slide and also the Young modulus. And we collect few data on the volume fracture of the composition and the tensile strength and the Young modulus. And the tensile strength and Young modulus value is used for the calculation. And for the NC simulation, a 3D CAD model is created where the shape is in dog bone shape ASTM D638, and we after creating it, we mesh it into 0.7% of mesh setting, and the fixed support is applied on one part of the dog bone, and the force is applied on the another part of the dog bone where the force is a pulling force. And the engineering data, we collect some data from the literature and we get the average of the Young modulus and the tensile strength to be applied to the simulation. And the suitable Young modulus value is 10,400 MPa, and also the tensile strength is 150 megapascal. And for the result and discussion in terms of mathematical approach, we can see when the carbon fiber content of the in the composition, when it is 50%, the tensile strength is high, where it is 1519 megapascal. And also for the Young modulus, the higher the carbon fiber content, the higher the Young modulus. And the stress is also calculated, where the stress is higher when the force of the applied is higher, and this stress is will be compared to the NC simulations stress result. And for the result and discussion on NC simulation, we tested using the dog bone shape, and the total deformation is obtained, where we can see the deformation before the fracture. We can see it on the orange region of the figure, and it shows the when the force is high and the deformation is also high. For the equivalent stress, we can see when we set a few forces, where it started from 5 kilonewton to 50 kilonewton. When the force is higher, the stress is also higher. Same goes to the equivalent elastic strain. And we calculated the average of the maximum equivalent stress and also the strain, and we did a graph on stress and strain curve, and we obtained when it is directly proportional. And for the conclusion of my project, the reclaimed carbon short fiber have a great opportunity to create new product, as it is suitable for repair application. Based on the mathematical approach, as the volume fraction increase, the physico-mechanical properties increase too. Based on the NC simulation result, the pattern of the result is exactly similar to the mathematical approach, even though the value is in a big margin difference. For the improvement of the study, it is recommended to conduct lab experiment where the extrusion parameter can directly influence the result of the composite properties. Thank you.